Now we're going to do a geometric sequence. And I'm going to give you an example of that, and then you'll be able to tell right away how it's different. So what if, for example, we had 2, and then 4, and then 8, and then 16, and then what would come next? Right, 32, right? 64, what's happening there? Are we adding? No, we're multiplying to get to the next number, right? So in a geometric sequence, we multiply to get to the next number. You multiply, come on. Multiply to get the next number. And the number that you multiply by is called the common ratio. So R equals 2 in this case. R equals 2, which is called the common ratio. And that's just whatever number you are multiplying by. And of course you might multiply by a fraction, which would make it smaller and smaller, but we'll get there. So now it says, write the first 4 terms where the first term is 3. Got it. Common ratio is 2. Multiply by 2 each time. 3, 6, 12, 24, 48. Easy, right? What if I said find the 9th term? Would you feel like multiplying by 2 every time? Or find the 12th term, right? So it's kind of the same thing where you count like, well, how many times did I really multiply by 2? So 1, 2, 3, 4. To find the 5th term, I started with the first term and I multiplied by 2 4 times to find the 5th term, right? And that's going to lead us to our new equation, which is a sub n equals a sub 1 r to the n minus 1, where r is the common ratio. And everything else has the same values, where that's the nth value of the nth term, value of the first term, and n, of course, is the number of terms. So here it says if the first term is 10 and the common ratio is 4, they want you to find the second term. Well, that's pretty easy, right? It's 40, right? Sorry, actually negative 40. But let's just say instead of the second term, let's say I wanted you to find the, I don't know, 12th term, something like that. The 12th term. So if I wanted you to find the 12th term, I would say, okay, a sub 12 equals a sub 1 times r to the n minus 1. Now here's the thing, because we're multiplying each time, our answers get humongous really fast. So sometimes it doesn't even fit on your calculator. This one does. Negative 419434040. So yeah, it's a pretty big number. Let's say, here's one where now the common ratio is negative, and it's a fraction. So this would go down to, what, positive 7, and then negative 7 halves. And by the way, never write these as decimals, because the decimals are just going to get, like, worse and worse and worse and worse, and you're not going to be able to have exact answers. Here I actually just did it for myself, didn't I? First, second, third, fourth, fifth term. So I didn't even use the formula, but I could have. This one is the 7th term. I'm gonna make this a sub 1. Just change it there to say the first term is 9. The r is negative 3. I like to do the first couple terms just so I kind of get a sense of the series, right? 4, 5, 6, 7. So 7th term. So if I use my formula, a sub 7 is a sub 1 times r to the n minus 1. And again, I can do that on my calculator. Negative 3 to the 6th, and I get 6561. Sometimes you don't need a formula. Like sometimes you can just kind of intuitively guess this one. Like here it's telling me that the 5th term, 1, 2, 3, 4, 5, the 5th term is negative 1, and it wants me to find the 100th term, but the common ratio is negative 1. What does that mean for the common ratio to be negative 1? See what's happening? Negative 1, positive 1, negative 1, positive 1, the first term, the second term, the third term, the fourth term. What's the 100th term going to be, negative 1 or positive 1? Right, positive 1, because all the even terms were positive 1, all the odd terms were negative 1. So you can do them by your intuition sometimes. Or here, like if, the 4th term is 1 over 81, I just want to find the 5th term. Common ratio is 1/3, so I'm just going to multiply that by 1/3, 1 over 243. 243. Here, again, I'm going to make this the first term. Most of the time it is the first term that we give you. The first term is 1/10. Common ratio is 1/10. So this is going to be 1 over 10 squared, 1 over 10 cubed, etc. If I want to find the sixth term, it would be the first term times the first term to the n minus 1. So actually that's going to be 1/10 to the sixth power. And it's fine to leave that like that. Probably guess we're going to do the next page as well, which is geometric series. And you could probably guess what a series is going to be. Just like it was with arithmetic, it's the same kind of thing where you're multiplying to get to the same number, but now we're adding up. So we're going to introduce the sum here. So the sum of the first 7 terms, if the first term is 4 and the common ratio is -3. Well, I could write these out. And again, they get so big so fast when you're multiplying. But like, I'm already annoyed with all those numbers. I really don't feel like adding them up. I should have had addition signs anyway, like in between all of these, right? That just seems like a lot of work, and it is. Answer here is 2188. We're obviously not going to have that be our strategy of writing them all out and adding them up. We got to have a formula. Here's the formula. S sub n equals a sub 1 minus a sub 1 r to the n over 1 minus r. R, of course, being the common ratio. Here's the nice thing. You don't need to know the nth term. It's so nice. So like here, if I want to find the sum of the first 6 terms, the first term is 6. It just happens to be 6 as the first term in 6 terms, but 6 minus, what's the r? 6, 1854, isn't that just 3? And then 1 minus 3. And I like to do the numerator on my calculator and then the denominator and then simplify it, but that's how it simplifies there. Similarly here, I'm going to look at that and say, okay, the common ratio is 1/2. I want to find the sum of the first 5 terms, so a sub 1 minus a sub 1 r to the n over 1 minus r. Now here's the thing, we want our answer as an exact answer, so no decimals. So sometimes if you type it in your calculator, you might get a decimal, no decimals. And so what you want to do is under math, you can do change to frac. Math change to frac will change your decimal to a fraction. Okay, we've got a couple more here, but I'm going to let it go because they're all kind of the same thing. Every once in a while you might have to use the first formula to find something that you're missing, but otherwise you can just plug them into the sum formula for geometric series.